This was our first Exponent Rules quiz. Here I have 4 raised to the third, which means 4 times 4 times 4. 4 times 4 is 16, times 4 would be 64. So my coefficient for that is going to be a 64. Next I have x raised to the third, which is x to the first raised to the third. Remember, when I have an exponent raised to an exponent, I multiply them. So x to the third. That really means x got used 3 times, x times x times x, which is x to the third. Same thing with the y's. That means y gets used 3 times, y times y times y, which is y to the third. So our first answer is 64, x to the third, y to the third. For the next one, similar situation, I have 3 raised to the fourth, which means I have 3 times 3 times 3 times 3. 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So for my coefficient, I'm going to have an 81. Here I have an exponent raised to an exponent, which means I can multiply them. So x to the 8th. If I was writing this out longhand, I would have x squared written 4 times. So x squared times x squared times x squared times x squared. And remember, when we're multiplying monomials, we're adding their exponents. So 2, 4, 6, 8, which would give me 81 x to the 8th. For the next one, I have 9 x to the 5th divided by 3x squared. Since this is division, I'll deal with the coefficients first. 9 divided by 3, which is 3, or I can also think of that as 3 over 1. And then when I'm dealing with the exponents and its division, I get to subtract. So 5 minus 2 would give me x to the third. So I would write this as 3x to the third. Some people might want to see that written out. They would put 9, which is 3 times 3, x to the 5th, x times x times x times x times x. On bottom, 3, and then x squared, x times x. This allows me to cancel out common factors. So the 3 is in common, the x is in common, the x is in common. So I'm left with 3x to the third. On number 4, I have 12x to the 4th over 16x to the 7th. Here I can't divide the 16 into the 12, but I can reduce those two. So once again, I'm going to write it as a fraction. I notice 4 goes into both of those. 4 goes into 12 3 times. 4 goes into 16 4 times. So we have 3/4. Here, if I do my subtracting, I have 4 minus 7, which is negative 3. And I notice that this is unhappy upstairs, so I'm going to move it downstairs, giving me a final answer of 3 over 4x to the third. If you're one of those who likes to see it written out, 12, if I broke 12 down, 12 breaks down into 4 times 3, and the 4 breaks down into 2 times 2 times 3. So this is 2 times 2 times 3. And then x to the 4th, 1, 2, 3, 4. Then 16, let's see, 16 breaks down into 4 times 4, which would be 2 times 2 and 2 times 2. So I have 2 times 2 times 2 times 2. And then x to the 7th, 1, 2, 3, 4, 5, 6, 7. And then I would cancel out common factors. Cancel out the 2 and the 2, and then an x and an x and an x and an x. Notice I'm left with 3 on top, 4 on bottom. 2 times 2 is 4, and then 1, 2, 3 x's, so x to the third. The next one, if I deal with the parentheses first, everything in parentheses, that means I have to go ahead and multiply this negative 5 times the x, so this is negative 5x. All of that is being raised to the 0. So we talked about anything being raised to the 0 was 1. The next one, I have 4x to the 6th times 4x squared. When I'm multiplying monomials, I multiply their coefficients. 4 times 4 is 16. and then I add the exponents. So x to the 6th times x to the 2nd would be x to the 8th. For number 9, I have negative 8x to the 3rd y times 9x squared y squared. Once again, I'm multiplying these two monomials, so I multiply their coefficients, which would give me a negative 72. Negative times positive is a negative. 8 times 9 is 72. And then I would add the exponents. So I have x's and y's. Let's go and count up the x's. I have 3 here and 2 here, so 3 plus 2 is 5. And then for the y's, I have 1 here and 2 here, so that would give me 3. The next one's a little different because it has addition. Remember, for addition, we have to have like terms to be able to add them together, which means I have to have the same variable with the same exponent, and here I do. I have x's, both raised to the 3rd. So all I have to do is add their coefficients. So 2x to the 3rd plus 4x to the 3rd would be 6x to the 3rd. Remember, I have to have like terms to add them together, and I don't change it in the answer. Number 9 is very similar to number 5, except its answer isn't 1. Here, instead of doing the stuff in parentheses first, we don't have parentheses. So we would go to what's next, which is exponents. This x is the only thing being raised to the 0. The negative 5 has a 1 up there. So this is x to the 0, which is 1. So I have negative 5 times 1. Negative 5 times 1 is negative 5. And last but not least, for number 10, I am multiplying 5x squared times 4x to the 5th. Since I'm multiplying the monomials, I would multiply their coefficients. 5 times 4 is 20. And then I would add their exponents. So I would have x raised to the 7th. 2 plus 5 is 7.